Hello. In this video, we're going to look at the details of solving linear equations. So I wanted to go ahead and start with some of the hardest kinds of linear equations we'll need to solve. And those are linear equations with fractions. We all hate them, so let's go ahead and try to see what we can do in order to deal with these equations. So what I like to do, it's not necessarily what you need to do, is multiply by the first fraction that I see, the first denominator I see, in order to eliminate it. And so if I do this, I get 5 minus, say, 30 over 3y minus 6 over 9. And then I can reduce. This is negative 10y, and this is 2/3. And now you'll see that I have this last fraction left, so I'll need to multiply again. So I'll multiply everything by 3. Now, life is a whole lot easier. This is a much easier problem to deal with. I can just add my 2 to both sides and divide by my negative 30. And yeah, this is a terrible number. I could not tell you off the top of my head what the fraction or the decimal expansion looks like. But this is a lot easier to solve once we got rid of the fractions. So, with this strategy, I like to eliminate the fractions one at a time. You don't necessarily have to do that. You could eliminate all of the fractions at once if you look at the denominators and find the least common multiple. In this case, it was 18. 6 can go 6, 12, 18. 3 times 6 is 18, and then 9 times 2 is 18. So the reason I like my strategy better is I don't have to sit and think about what is the least common multiple. I don't have to do this extra work. I can just get started and get rid of my fractions. So again, I could look over here for this next one and say 4, 2, 3, what is the least common multiple? Or I can just start getting rid of fractions. Like this first fraction. So I'll multiply everything by 4. Get w minus, well, 4 times negative 1/2 would be minus 2. Negative 12w plus. All right, well, looks like we'll need to multiply again because I didn't get rid of that 3. So this time I'll multiply everything by 3. And what that tells me is my least common multiple is 4 times 3. So that was the number I could have multiplied by in order to skip that first step. But now look at how easy this is. This is way easier to deal with. I'll add my 36w to both sides. I'll add my 6 to both sides and divide by 39. And again, even more so than last time, no idea what this decimal expansion is. But once I was able to get rid of the fractions by multiplying, it became a whole lot easier. So now let's look at one. The fractions look slightly different, but we can still do the same thing. I'm going to multiply everything by 2 first. So I'll get these to cancel. All right, let's stay in this color first. So the 2's canceled. I'm just left with my numerator, 3u minus 6. And then now in this case, I'm just going to leave it as negative 2u minus 1. all over 7. So I still have a second fraction. I'll multiply everything by 7. And you'll see I have this whole big thing together as one unit. And that's why I left this alone. So I get 28 equals 21u minus 42. And then this canceled. So we're left with that negative 2u minus 1. And I like to do this just so that I remember to multiply and distribute that negative 2. If you wanted to, you could have distributed up all the way up here. All right, but now it looks exactly like the others, except maybe I have to do a little bit more work. Oh, 2. So I'll combine my like terms. I'll move the 40 over. And then, oh, wait. 21 minus 4 is 17. There we go. That looks way worse. Which helps me drive home the point. It doesn't matter how ugly the answer looks. If I have fractions in my equation, I can multiply by the denominators until I'm rid of all of the fractions. And then life will be easy all the way up until I solve it. So I have 2 more examples to look at. And you'll see this one, it doesn't look that complicated. Right? I could go ahead and just start distributing. I'll combine my like terms. And then I see something weird happen. If I want to get the x's all to one side, I'll subtract 10x from both sides, and I'm left with 17 equals negative 15. Now, this is absolutely not true. And what that tells me, there are no solutions. It tells me that it doesn't matter what I plug in for x, this will not work, ever. And that makes sense, because if this here is some line, and this here is some line, what does no solutions mean? It means I have 2 lines that don't touch. And we kind of knew that after we multiplied it out, we saw it was 10x plus 17, so slope of 10. 10x minus 15, still slope of 10. So we can see here, if when we solve, we get to something that is definitely not true, then that means there are no solutions. Which means the opposite will also be a case. If, while I'm solving it, let's see, 2 and negative 6 is negative 4. Well, you'll see the left and the right is exactly the same. I could keep going, sure. But this is always true. It doesn't matter what I plug in, it's always true. Which means that everything is a solution, or the solutions are all real numbers. And all that means is, well, if I had negative 4u minus 4 equals negative 4u minus 4, they were just the same exact line. So where do they overlap? Everywhere. All right, and those are all of the tricky cases when we're trying to solve linear equations.